Now let's just move on further and see a question which is related with the representation of irrational numbers on the number line. So the question number 1 says represent root 2, root 3, root 5 on number line. It means that now we have to represent these 3 irrational numbers all together in a single number line. So let's just start the construction or the representation of root 2, root 3, root 5 on the real number line. So let us suppose first of all we are taking this number line and we are taking any particular point O on it. So in order to represent root 2 on the number line, we do know that we always have to take the base as 1 unit. Always remember 1 unit is nothing but 1 centimeter. So let us suppose if I am taking the scale or using the help of the scale, I am taking OA as nothing but of 1 centimeter. Again, we have to take the perpendicular AB as nothing but of 1 centimeter. It will join OB. Then using the compass, taking O as a center, OB as a radius, we can mark an arc. Over here in such a way that this particular point A1 or the distance OA1 is nothing but definitely root 2. Now let us suppose we are taking root 3 further. So in order to represent root 3 on this number line, now I am taking a perpendicular distance of 1 centimeter or of 1 unit at the point B. I'm not taking it further. I'm not representing root 3 further like we did before, because we just have to represent all these 3 on one line all together. So in order to represent root 3, now I am taking a perpendicular at the point B and I'm taking 1 unit distance. I'm taking 1 unit distance or 1 unit perpendicular over here, such that I'm calling it as BB1. Always remember B1B is perpendicular to OB. B1B is perpendicular to OB such that it is of 1 unit. Now let's just join OB1. And definitely we do know that if the base of this particular triangle is root 2 and if the perpendicular is 1, then definitely the hypotenuse is nothing but root 3, because root 2 square is 2 plus 1 square is 1. 2 plus 1 is nothing but 3, and definitely with the help of the Pythagoras theorem we can conclude that OB1 is nothing but root 3. Now again using the compass, taking O as a center, OB1 as nothing but the radius, mark an arc on the number line over here such that I'm calling it as A2, such that this distance OA2 is nothing but root 3. This distance OA2 is nothing but root 3. Now let's just move on further towards root 5. So let us suppose again I am constructing a perpendicular of 1 unit distance on OB1 again. Let us suppose I am constructing a perpendicular over here again which is of 1 unit. So let us suppose I am constructing a perpendicular over here again which is of 1 unit. Always remember this is perpendicular to OB1. Let us suppose I am calling it as B2. If I'll join OB2 all together, then this is nothing but of root 4. We can again use the Pythagoras theorem on the triangle OB1B2. We can use the Pythagoras theorem on the triangle OB1B2. Let us suppose if I am taking this particular triangle over here as we have OB1, as we have O, this is our B1 and this is our B2. As we know, OB1 is nothing but root 3. This is nothing but 1. So let us suppose if I'm taking the Pythagoras theorem over here. So we know that OB2 square is definitely is equal to OB1 whole square plus of B1 B2 whole square. So if this is root 3 square, this is 1 square. So this will be 3 plus 1, which is nothing but 4. It means OB2 whole square is 4, which implies OB2 is definitely root 4, and we can also call it as nothing but 2. It means OB2 is nothing but 2 using the Pythagoras theorem. But we just wanted to find out root 5, not root 4. It means that we have to move on further following the same steps. So again, let us suppose I am constructing, let us suppose I am also taking O as a center and OB2 as nothing but the radius. I am making an arc over here. Then definitely this A3 point is nothing but root 4, that is 2. But we wanted to find out root 5 on the number line. So let's just move on further. Let's just have 1 unit perpendicular again over here, such that I'm calling it as B3. I'm joining OB3, taking OB3 as a radius. Now again using the compass, I am just making an arc over here. So this is nothing but A4. So this distance OA4 is actually root 5. This is actually root 5. So this is all about the representation of root 2, root 3, root 5 on the number line. So let us suppose if I'll mark it over here, from O point till A1, let us suppose this is my A1. This is nothing but root 2 representation. From this point till this point, till this A2, this is my A2, okay. So this is my A2, this is nothing but root 3 representation. And from this point till so goes on A3, this is nothing but root 4, that is also we can call it as 2. And from this point till so goes on A4, this representation, this is nothing but root 5. So this is all about the representation of root 2, root 3, root 5 on the number line. So let's just write all the steps of constructions that are related with the representation of all these. So let us suppose I am taking the steps over here. So let us suppose I am writing the steps over here, steps. So let's just write the step number 1. Take a number line. And mark any point O. Second, always remember 1 unit is 1 centimeter over here. 1 unit as 1 centimeter. So draw OA as 1 centimeter or 1 unit we can also say, and draw a perpendicular AB on OA such that AB is also of 1 centimeter, or we can say 1 unit as well. Now further, the third will be, let us suppose I'm writing it over here again, join OB. So using compass, taking O as a center, mark an arc of radius OB, on the number line, and call it as A1, say. Let us suppose we are calling it as A1. Let us suppose say. So the step number 4 would be like, draw BB1 perpendicular to OB such that BB1 is of 1 unit again. Further, join OB1. So using compass, taking O as a center, OB1 as a radius, mark an arc on the number line, and take it as or call it as A to say, or A to say. Let us suppose we are writing over here such that OA2 is nothing but root 3. We can also write it over here such that OA1 is nothing but root 2. Now let's just move on further. 5. Draw again further. Draw B2 B1 perpendicular to OB1 such that B2 B1 is again of 1 unit. Further, join OB2 using compass, taking O as a center, OB2 as a radius. Mark an arc on the number line, and call it as A3 say, such that OA3 is nothing but root 4. So the step number 6 would be like draw B3 B2 perpendicular to OB2 such that B3 B2 is 1 unit. Join OB3 using compass again, taking O as a center again, OB3 as a radius again, mark an arc on the number line, and call it as or take it as A4 say. Let us suppose we are taking it as A4 such that OA4 is nothing but root 5. So the step number 7 would be like, let us suppose I am writing it over here. The step number 1 would be like OA1, or we can say this is the required representation of root 2, root 3, root 4, root 5. So at the end, this is the required representation of root 2, root 3 and root 5 as OA1 is equal to root 2, further OA2 is equal to root 3, further OA3 is equal to root 4, and further OA4 is nothing but root 5. So this is all about the representation of root 2, root 3, root 5 on the number line. I hope all the steps related with the representation of these irrational numbers on the number line is all clear to you.